The Soviets lost the moon race the moment Neil Armstrong set foot on the moon. That's the part you remember. There was a second spacecraft above his head, a Soviet one. It had arrived 3 days earlier. And by the time it tried to land, they were just hours from coming home. And if Russian engineers had made one different decision 4 days before, the first sample of moon rock to reach Earth would have been Soviet, not American. The man who decided whether or not to tell the Americans this spacecraft existed was named Mstislav Keldysh. He was one of the founders of the Soviet space program. And in the second week of July 1969, he made a phone call that had never been made before in the entire Cold War. This is the story of what the Soviets were actually doing while America was walking on the moon, and how close they came to winning the part of the race that nobody was watching. To understand what was happening in 1969, you have to go back to a fight that started 7 years earlier between two men who hated each other, Sergei Korolev and Valentin Glushko. Korolev and Glushko had a problem. Back in the 1930s, during Stalin's purges, Korolev had been arrested and sent to a gulag. He spent time in Kolyma, which was one of the worst places a human being could be sent in the 20th century. And Korolev believed, for the rest of his life, that Glushko was the man who had informed on him. That's the disagreement that shaped the moon race. A grudge. When the Soviets started seriously planning to put a man on the moon, they needed a giant rocket. The Americans were building one called the Saturn V. The Soviet equivalent was called the N1, and the question of which engines would power the N1 split the program in half. Glushko wanted to use one kind of fuel, hypergolic propellants. Toxic, but they ignite on contact, which makes the engine simpler. Korolev wanted kerosene and liquid oxygen, the same thing the Americans were using. Korolev thought hypergolic fuel was too dangerous to put a cosmonaut on top of. Glushko pointed out that the Americans had already flown crews on similar fuel, and it was fine. A committee was appointed in 1962 to settle the dispute. The committee agreed with Korolev. Glushko's response was to refuse, to design any engine that ran on kerosene and liquid oxygen. He also refused to work with Korolev on anything else, ever. So Korolev had a giant rocket on paper, and the only man in the country who could build the engines for it had walked off the project. He turned to a man named Nikolai Kuznetsov, who designed jet engines for aircraft. Kuznetsov had limited experience with rockets. What he came up with was a fairly small engine called the NK-15, and to get the thrust the N1 needed, you would have to use 30 of them at once, all firing together. 30 engines, all of them firing at the same time, none of them ever tested as a complete cluster. That last detail is the one that mattered. Because the launch site at Baikonur could not be reached by heavy barge, every component of the N1 had to be shipped in pieces by rail and assembled when it got there. The Americans built their Saturn V in one place and tested every piece. The Soviets could not. The valves on the engines were operated by small explosive charges instead of mechanical means, which saved weight, but which also meant that once a valve had been fired, it could not be reopened. So the engineers could only test individual engines, one at a time. The whole cluster, all 30 of them firing together, was something that, in the available record, would only ever happen on a real launch. Then, in January 1966, Korolev died. The man who took over was his deputy, Vasily Mishin. This is the program that was supposed to beat the Americans to the moon. The first attempt to fly the N1 came on the 21st of February 1969. About 6 seconds into the flight, vibrations from the engines started shaking pieces off their mounts. A fuel line ruptured. Fuel started leaking into the back of the rocket. It caught fire. The fire burned through the wiring, and the wiring sent a confused signal to the engine control system, which decided that the entire first stage needed to shut down. So it did. All 30 engines, all at once, 68 seconds into the flight. The rocket fell out of the sky and crashed about 30 miles from the launch pad. That was the first launch. The second one was worse. On the 3rd of July, 1969, less than 2 weeks before Apollo 11 was scheduled to lift off in Florida, the Soviets rolled out a second N-1 to the same launch pad. They lit the engines just after midnight Moscow time. The 30 engines fired, the rocket cleared the tower, and then a turbopump in engine number 8 exploded. The shockwave from the explosion severed the propellant lines around it. A fire started. Engines started shutting down one by one between 10 and 12 seconds into the flight. At 15 seconds, the launch escape system fired and pulled the dummy spacecraft on top of the rocket up and away. At about 23 seconds, the rocket leaning at a 45-degree angle, with one engine still inexplicably firing, fell back down onto the launch pad. Almost 2,300 tons of fuel and oxidizer were on board. The explosion was visible from the city of Leninsk, 22 miles away. It is still considered one of the largest accidental non-nuclear explosions in human history. Launch Complex 110 East was leveled. The concrete pad caved in. A lighting tower was knocked over and twisted around itself. Half an hour after the blast, when the launch crews were finally allowed outside, droplets of unburnt rocket fuel were still raining down on them from the sky. This happened 13 days before the launch of Apollo 11. The Americans found out about it almost immediately. Spy satellites flew over Baikonur and photographed the destroyed pad. The intelligence community had been watching the N-1 program for years. A US reconnaissance satellite had photographed an N-1 mock-up on the pad as far back as November 1967, and President Lyndon Johnson had been briefed on it the following month. NASA Administrator James Webb had access to all of it. So when the Americans saw the wreckage of the second launch, they knew exactly what they were looking at. The Soviets had just lost their only realistic chance of putting a cosmonaut on the moon before the Americans got there. Now they had a different question. Could they still beat the Americans home? This is where the story shifts. Because if you cannot land a man on the moon, you can still land a robot. And if the robot can scoop up a handful of dust and bring it back to Earth before the Americans return with their bag of rocks, then for the rest of human history, you can argue that you were the first to bring a piece of the moon home. The plan was drawn up in about 6 months. A spacecraft small enough to be launched on the existing Proton rocket, a robotic arm that would scoop a sample, a small return capsule mounted on top that would launch off the lunar surface and head back to Earth. It was called Lunar 15. It was launched on the 13th of July, 1969, 3 days before Apollo 11 lifted off from Florida. By the time Armstrong, Aldrin, and Collins were strapping themselves into their command module on the morning of the 16th, Lunar 15 was already most of the way to the moon. This is when the Americans found out about it. Now let's bring in the man at the center of this, Mstislav Keldysh. In early July of 1969, with launches scheduled and the world's attention closing in on Florida, an Apollo astronaut named Frank Borman was on a goodwill tour of the Soviet Union. Borman had commanded Apollo 8, the first crewed flight to orbit the moon. On the 5th of July, Borman became the first American astronaut to visit Star City. He met cosmonauts, and he was introduced to Mstislav Keldysh, president of the Soviet Academy of Sciences. This was a strange meeting. Borman was an American military pilot in the middle of a Cold War. Keldysh was one of the men who had built the Soviet space program from its foundations. They shook hands, they had a conversation, and then Borman flew home. A few days later, the Soviets launched Lunar 15. Nobody at NASA knew what it was. They could see it. They knew it had entered an Earth orbit, and then a translunar trajectory, and then a lunar orbit. But they did not know the orbital parameters. They did not know whether it was going to land. And the Apollo 11 crew, on its way to the moon, was about to share that small volume of space with an unknown spacecraft they had not been briefed on. Armstrong said in 2009 that he and his crewmates did not know about Luna 15 or its goal until they were already en route. The moon's surface, as NASA's chief historian William P. Barry put it, is about the size of Africa. There was, in theory, plenty of room. But orbital dynamics meant that the most efficient places to land were near the lunar equator. That narrowed the area drastically. The Eagle, the Columbia, and Luna 15 might end up sharing a much smaller piece of sky than anyone wanted. Somebody at NASA needed to find out what the Soviets were doing. There was, in 1969, and it was a Frank Borman, so Borman picked up a phone and contacted Keldysh. What happened next, William P. Barry told the Washington Post, was unprecedented in American-Soviet space relations. Keldysh telegraphed the orbital details of Luna 15 to the United States. He confirmed it would not interfere with Apollo 11. He did not, of course, tell them what the spacecraft was actually for. The mission's real purpose stayed classified, but the flight plan came across. This was not a small thing. It was the first instance of direct technical cooperation between the Soviet space program and NASA. It happened in the middle of the most intense moment of the moon race, while Apollo 11 was already on its way. Keldysh authorized it. The Soviet government allowed it, and it was made possible by a handshake that had happened a week earlier at Star City. By the 17th of July, Luna 15 was in lunar orbit. It would stay there for 2 days while Soviet controllers checked its systems. It performed 2 orbital adjustments. It completed 86 communications sessions with ground control. It circled the moon, eventually 52 times. Down in Houston, flight controllers told the Apollo 11 crew that Luna 15 had entered orbit. The American crew, 3 days from their own landing, kept track of where the Soviet spacecraft was every time they came around the far side of the moon. Both spacecraft made small orbital corrections. Ground controllers in both countries watched and waited. On the 20th of July, at 20 minutes past 4 in the afternoon Houston time, Eagle touched down in the Sea of Tranquility. A few hours later, Armstrong climbed down the ladder. Luna 15 was still in orbit. The original plan had been for Luna 15 to land hours before Apollo 11, but the Soviet controllers had a problem they had not anticipated. Their landing site was Mare Crisium, the Sea of Crises, and they were getting their first real look at what it actually looked like from above. The terrain was rougher than they had expected. There were ridges, craters, and there were features that could easily destroy a small lander on touchdown. So, they delayed. They studied the surface. They ran the numbers again. Hours of orbit became a full extra day. They were, in their own quiet way, doing exactly what the Americans had been doing for years, agonizing over a landing site, trying to make sure their spacecraft did not crash into a mountain. The irony is that this is precisely what happened to it. By the time the Soviets finally committed to a landing, Armstrong and Aldrin had been walking on the moon for hours. They had taken photographs, they had planted a flag, and they were preparing to climb back up the ladder and lift off for home. The Soviets realized, one source after another tells us, that they were running out of time. If Luna 15 was going to grab a sample and beat the Americans back to Earth, it had to land now. It was the 21st of July. There were less than 2 hours until Apollo 11 was scheduled to lift off from the lunar surface. It was now or never. At 47 minutes past 3 in the afternoon Universal Time, Luna 15 fired its main retrorocket and began its descent. A few thousand miles away, at the radio telescope facility at Jodrell Bank in England, a team of British astronomers led by Sir Bernard Lovell was listening. They had been tracking the spacecraft for days. The Soviets had not told them, or anyone else outside of Moscow, that this was a landing attempt. The astronomers thought it was an orbital mission. They were unaware, until that moment, that the spacecraft had a lander at all. Then they heard the engine fire. There is an audio recording of those minutes. It was kept private for 40 years. It was first released to the public on the 3rd of July, 2009. On it, You can hear British technicians narrating what they are hearing in real time. At one point, one of them says, in the kind of clipped British understatement that seems impossible when you know what they are listening to, I say, this has really been drama of the highest order. The descent engine was supposed to fire for 267.3 seconds. It fired for 237. Then, the signal cut out. What happened in those 4 minutes is something we have had to reconstruct from telemetry. The spacecraft was descending toward Mare Crisium. Its attitude, the angle at which it was pointed when the engine ignited, was off by several degrees. It was not descending straight down. It was descending at a slight angle, which meant that instead of slowing toward the surface, it was being pushed sideways across it. It hit the side of a mountain. The impact speed was about 298 miles per hour. The crash site was about 350 miles away from where Eagle was sitting in the Sea of Tranquility. The time of impact was 50 minutes past 3 in the afternoon Universal Time, 2 hours and 4 minutes before Eagle was scheduled to lift off. By any reasonable definition, the Soviet attempt was over. But here is the part that gets buried. They did not lose at 4:17 on the 20th, when Eagle landed. They lost at 3:50 on the 21st, when Luna 15 hit the side of a mountain in the Sea of Crises. NASA's chief historian William P. Barry put it as plainly as anyone has. The race to the moon ends when Luna 15 crashes. The clock did not stop until the Soviet spacecraft did. The day after, the Washington Post reported the crash. A reporter named Howard Simons wrote that the parallel missions had been a spaceflight riddle wrapped in a mystery inside an enigma that had ended in irony. Some scientists at the time speculated that the Soviets had crashed their spacecraft on purpose to clear the lunar orbit of any debris that might pose a long-term hazard. The Americans had done the same thing with their own spacecraft. It was a polite theory. The Soviets did not contradict it. What they also did not do, for the next several decades, was admit what Luna 15 had actually been. The mission's real purpose, to grab a handful of soil and beat the Americans back to Earth, was not officially confirmed until after the Soviet Union collapsed in the early 1990s. Until then, the Soviet position was that Luna 15 had been a study mission, an orbiter, a scientific exercise. Anyone who suggested otherwise was speculating. The bones of the spacecraft are still up there. NASA's own historians have said that finding the wreckage now would be almost impossible. Distinguishing a small crater caused by Luna 15 from a small crater caused by a meteorite, William P. Barry pointed out, would be very hard. The spacecraft is somewhere on the side of a mountain in Mare Crisium. The exact place is no longer known. It would be easy, after all of this, to write the Soviet moon program off as a failure. A lot of people have, but that would miss what happened next. Now let's come back to the engineers who built Luna 15, because the team responsible for the spacecraft did not stop working on the day it crashed. They were the planetary scientists and engineers of the Babakin Science Research Center. They had taken over the robotic exploration of the solar system from Korolev's old design bureau in the early 1960s. They built the hardware. The Lavochkin Production Organization, which had been famous during the Second World War for building Soviet fighter aircraft, manufactured the spacecraft. The Proton rockets came from the Khrunichev factory. They were a system. And the system did not stop just because one of its missions had hit a mountain. 5 separate lunar sample return missions failed before one of them worked. The team kept going. They redesigned. They tested. They flew. In September 1970, Luna 16 landed in Mare Fecunditatis, the Sea of Fertility, about 100 kilometers west of Webb Crater. Its drill penetrated the lunar surface. It collected 101 grams of soil, about the weight of a small candy bar. It transferred the sample to a return capsule. The capsule lifted off the surface, returned to Earth, and parachuted down into Kazakhstan on the 24th of September. It was the first time in history a robot had landed on another world, collected something, and brought it home. The Apollo astronauts had brought back hundreds of kilograms of rock. The Soviets brought back about 100 grams. The American number is bigger by an enormous margin. But there is something the Soviet number does that the American number does not. Luna 16 did the entire mission with no humans on board, no pilots, no commanders, no astronauts. The entire flight, from launch through descent, through sample collection, through ascent, through re-entry to a parachute landing in Central Asia, was conducted by machines. Luna 20 followed in February 1972, returning 55 grams of soil from the Apollonius Highlands. Luna 24 followed in 1976, drilling deeper than its predecessors and bringing back about 170 grams of soil from Mare Crisium, the same Sea of Crises that had killed Luna 15. After that, there were no more. The Soviet Union never sent another spacecraft to the moon. Russia has not sent one since. In December 1976, NASA and the Soviet Academy of Sciences exchanged a gram of lunar sample with each other. The Americans had brought back 382 kilograms. The Soviets had brought back about 226 grams. They traded 1 gram each. After everything, the rocket explosions, the engine grudges, the dead chief designer, the spacecraft on the side of a mountain, the unprecedented telegram from Keldysh to Borman, the two programs ended up swapping a small amount of dust as a courtesy. In 1978, Soviet scientists at the Vernadsky Institute in Moscow published a paper claiming they had detected water in the Luna 24 samples, about 0.1% by mass. It was the first claimed direct measurement of water on the surface of the moon. For decades, the result was viewed with suspicion. The Vernadsky scientists themselves were not willing to go on the record saying their samples had not been contaminated by terrestrial water during handling. Most Western researchers considered the result inconclusive. The moon, they thought, was dry. 40 years later, a series of missions, American, Indian, Chinese, confirmed that the moon was not dry. There was water, there was hydroxyl, there were ice deposits in permanently shadowed craters near the poles. The Vernadsky Institute had been right, in a strange and unverifiable way, with a sample brought back by a robot launched by a country that no longer existed. There are things we still do not know about Luna 15. We do not know exactly where the wreckage is. We do not know what the spacecraft saw in those last few seconds, after the engine fired at the wrong angle and started pushing it sideways across Mare Crisium. We do not know what was in the final telemetry packet that arrived at 4 minutes into a 5-minute descent. We do not know whether the Soviet engineers, in the control room outside Moscow, understood what had happened in the moment, or whether it took them hours of analysis to work out that an attitude error had cost them the race. We do not know whether Luna 15, even on a clean descent, would have made it home before Apollo 11. Some sources suggest its return trajectory after the orbital delays would not have been fast enough. The honest answer is that the question never got tested. What we have, instead, is a picture. Somewhere on the side of a mountain in the Sea of Crises, 350 miles from where the American flag was planted, there is a piece of metal. It is bent and broken. It has been there since the 21st of July, 1969. The sun has crossed over it about 700 times. No human eye has ever seen it. No camera has ever photographed it. Its precise location is unknown and may stay unknown. It is still there.